Welcome back to part 3 of Spider Robot Project. So, we're just gonna wait 5 minutes or something until people flock in, if anyone's coming, and then we're gonna start. All right. So, last thing we did regarding this project is we mated everything in here. Also, we finished part of the leg, and then we finished part of the femur. So we have a tibia and then a femur. We finished the entire tibia, which is this one in front of you right here. And then we started part of the femur, and then I finished a little bit of it on my own time, which is this. We're still gonna work on it a little bit, and then try to mate everything together, try to make a bracket for the servos, try to make them better, try to connect everything. If we're able to do this in the stream, that'd be great. If not, then there will be a stream tomorrow as well. So let's see what we can finish up in this stream, and hopefully everything goes well. So buckle up. Regarding this one first, since we have it open, let's just shave it a little bit because I don't like how this looks. Let's just make some like this. Actually, let's then this starts from here. Yeah, let's cut it from here. Yep, that would be great. Let's do this. Something like that. Here. Yeah. So we're cutting this off. Nope. Come on. Yep. This. Yeah, Farid. Let's go. Okay, so we will see how that looks. Hopefully it looks better than it shows in here. Let's do this. Okay, so we're cutting this. We're gonna finalize the what's it called? We're gonna finalize the dimensions later. We just want to see how it. Okay. Let's do through all. Yeah, much better. I mean, look at that. Look at that. Look at that. Beautiful. Beautiful. It still has some work to do, of course, but for now, this is way better than it looked. Because we want this tip, in the end, this tip in the actual thing, it's gonna be replaced by either rubber, plastic, or whatever you want to grip on the floor. If you have slippery floors, or if you just are doing it using PLA or ABS. So it will all be one material if you're using that. Or if you're making this spider using metal right away, then this will do great. You can also cover it with resin or something that has friction, so it will do great. So this part can either be replaced or not. So we're just gonna leave it at that for now. And we're gonna go for these. We're gonna do, um, we're gonna unmate all the servos that we did here and made them backwards. So this top part is gonna be looking down, and we're gonna like open some spaces for it, because this is not gonna work out to be like this. We need to fasten this to the floor. So these screw holes are gonna look down, and then we're gonna screw them using actual screws. Like in real life, there are gonna be screws through here to the body of the spider, as well as in the actual. I'm just, as I said in my previous live, we're just trying to put everything together in here so we can simulate the design. So according to that weight, we're gonna calculate how much our legs are actually gonna handle, how much these parts can handle from the simulation. So what we need to do is make sure that these can handle a certain amount of weight. So we're not looking to make it pretty right now. We're just looking to make all the components in there. But in the actual design, this is gonna be one floor for the camera, and then all the the camera and the lidar actually, and then everything else, everything electrical. So these are the batteries. This is the Jetson Nano and so on, and the driver and all of that. All of that is going to be in the second floor down here. There's going to be another one of those down here. Everything electrical is going to be hidden inside here. It's going to have ducts for the cables and everything. So it's going to get prettier. For now, we just want to start our simulation and see how much our LEDs can handle, so we can adjust the LEDs width, height, and everything starts from there. So if the LEDs can handle this amount, of course we're gonna add more weight to everything. So assuming, for example, this is like 200 grams, we're gonna say it's 300, and this, if it's 100, we're gonna say it's 150, and so on and so forth, and to make sure that we're in the safe side. So let's get started and unmate everything here regarding the servos, and push them down and open holes for them. So let's go. A little bit slower than I expected, but better safe than sorry. We don't want to unmate something that we actually need, because it's gonna get annoying when we actually put all of this together to keep track of what we mated and what we didn't. Where is the rest? Yeah, we did until 4. And also with my fish brain, you really don't wanna miss anything. Cool, last mate. So now they can freely move. Great. Okay. So now we want to mate this. So we need these things to look down. So we're gonna mate this. Come on, you can do it. Flip it. Thank you. And here we go. So we're gonna see where that is. This is gonna go here. Thanks. Flip it. Let's do distance, so we can have those screw holes fit in somewhere here without actually causing any tension at the tip here. So let's do a distance, for example, of what do we want? We want some like so first we want it like that, and then we want it something like flip dimensions. 7 is too much, so let's make it 3. Yeah, 3. Actually, let's make it 2 centimeters. Great, 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 great. Okay. Alright, that looks awesome. Alright, alright, alright. So, let's have this away from this by... what do we want it to be? Let's distance. Let's look at it. Actually, never mind. Let's look at it from here. So if it's 10, that would be there, yeah. 10 is cool. Let's do this. Yep. Nice. So 10, we're gonna make it 5 centimeters apart. This is considered 10, so 5 and then another 5. Or 6 and 6, actually. That would be great. Okay. 6 and 6 it is. Let's first have this. Flip it. Thank you. This and this. Flip it. Nice. This and flip. We're gonna fix everything, don't worry. Nobody panics! Nobody panics! Okay, way better. Alright, so we want this to be in line with this. Nope, flip it. Thank you. And this to be in line with the same thing. Also flip it. Thanks. So, we want this and this to be distance of 5. We said 6? Yeah, we said 6. 6 centimeters. And this would be another 6. But the other way around. Cool. So yeah, 6 is, as you can see, yeah, it fans out pretty nicely. Alright, let's do the rest. So this should be here. Flip. Do a distance. I said flip. And do a distance. Where did it go? Cool. So we did 2 centimeters, I guess. Yep, that's what we did. And then we did here to here as 10 centimeters. Cool. Then we're gonna do these. Sixes. Nope, not this. This one. We doing the distance. La distance. Cool. So if we stop mating and check, yep, they're all fastened. They're all fully defined. Thank you for reminding me to save. Okay, it's not moving. Just make sure. Sometimes it bugs out. We don't want that. And another save here. Okay, so we're gonna remove this later. So this is clipping through, of course, as you can see. So we're gonna remove the whatever material that we're gonna use. Let's say PLA. We're gonna remove the PLA that's here and just make a hole for it. But that's later. So for now, this is how it's supposed to look like. These are just gonna get connected to what's it called? The what's it called? I forgot. Yeah, a bracket, then the tibia. That bracket connects to the servo that's on the tibia, and then the tibia to the femur. Yep. Cool, cool, cool. Alright. Now, let's get what do we wanna add? Should we add this right now? Let's insert one tibia. Actually, no, that's nope. Let's insert one femur. All right, perfect. Okay. So is it? This is where the other servo goes. Let me just add the servo here. We're supposed to add 6 more. Insert servo. But first, let's try it with one leg and then we're gonna insert the rest. Okay, so here's what I was thinking. We're gonna have this. What was I thinking? I had something in mind right now and I forgot it instantly. What was I thinking? I genuinely forgot. So there's gonna be a bracket attached to this. That bracket will connect to this entire thing. Let's just make 2 brackets for it. Yeah. So I genuinely forgot the idea that I had in mind. Anyway. Where did we want to make that bracket? Okay, let's open this. Open part. Okay, so we want to look at it from this angle. We need this to be inserted in a bracket. Good God, I can't see anything. Oi. Okay, let me actually check it out, because my mind just drew blanks. Great. Where was it? There. You guys cannot see what I'm checking out right now, but I'm checking something out. Huh. Okay. Let me check something out other than this. Let me actually just do this. I'm gonna show you guys what I'm looking at. One sec. Cool. Now you can see it. Great. Alright, so servo 35. I just wanna look at pictures of it. You guys can see that, right? Yep. Yeah, okay. So, I want to see the bottom of this. Oh, yeah. Just checking out a couple of images for it, because I need to see how the bottom fits. I need to see that part. That's like in line with the center of this card right here. Because the reason I'm checking this out is when people do these kind of designs, which is something like that, you see that this is where we're gonna connect this servo to the bracket or wherever it is gonna be attached to, which is something like that. But in the other side, so you want all of this to work together as one thing. So this is attached to something at the bottom.
So if it's not attached to the servo itself, then it's attached to the bracket itself. So that's what we might do actually, instead of just drilling through. I thought there was, because some servos come with an opening at the bottom, adjacent to that, to work as an entire shaft. But if it doesn't come with a hole at the bottom to attach a screw or something, we would have to make that bracket and then just make this screw into the bracket, you know? That's what I was checking. So for now, until further information arise, we're gonna have to make a bracket, an entire bracket for it, to avoid any conflict. Yeah, I'm not checking the. I'm not checking what's gonna be connected here. I'm not checking if it's gonna be the thing that looks like an L or the round one. We might do the round one, but I'm checking at the bottom of the servo how it looks like. Yeah, so this is not what I'm checking out. I'm not checking if we're gonna use this or the round ones, which are these. I just want to see the bottom of the servo itself. But none of it is showing the bottom, so yay. We're just gonna have to make a bracket for it, just in case, because that's the safest option. So let's go for the bracket. Alright, so we need all of this to be inserted inside a bracket where it has somewhere for those cords to come out. We need these to be inserted somewhere that it can be screwed on, and then we need something adjacent to this to come out here and be screwed all together. Alright, let's make another part. New part. Okay, where do we want to look at it? We want to look at it from the top. Alright. Let's do this. Come on. You can do it. Hello? It's not moving. Yep. There we go. Let's close some parts actually, because this is gonna make everything slower for me. My laptop can't take it. My laptop can't take it. One day. Oh, you actually can't see what I'm doing. Okay. There. Where was I? Oi, oi, oi. Yep, there we go. So I need to keep this open so I can insert the bracket and fit it right away and see how it goes. So we're just gonna keep those three open, which is the assembly, and this to take the measurements, and then this because that's what we're making right now. Okay, so let's start measuring. All of this is gonna be from here to here. Let's say 40 millimeters. this side. Okay. 20. And then... Nope. And then... From here... to here. So 20 and 32. Then actually though, let's make it so we're adding. You're gonna understand what I'm doing right now in a sec. So we said this is 40 millimeters. We want to add 5, yeah. We want to add 5 millimeters from this side and then 5 from this side. So we're at 10, so we want this to be 50 millimeters. And same here, we're gonna, instead of 20, we're gonna have this to be 30 millimeters. You're gonna see why in a sec. So we said we're gonna raise it to be 32. Right, 32 millimeters. So it's gonna be 32. We wanna add another 5, so that's gonna be 37 millimeters. Yes. And now we are gonna extrude cut here. Extrude cut this like that. Now this is gonna be 40 millimeters, and then 20 millimeters, and then we're gonna go down the 32 that we needed. 32. Perfect. Our servo is just gonna fit in there. So here we go. What else? It's gonna have where is this? It's gonna have need to get into the sketch of this. Nope. Not that. I need to know where this is compared to this. So how do we do that? Oh yeah. The dude who built this is awesome and everything, but I need the dimensions. This here. Okay, what's that? Okay, we can work with that. Alright. Can we do... Can we look at it from here? Mark that. Now I need the measurements of this. Where was it? Measure. I need from here to the center of this. Yeah, boy. Hey, that's exactly what I need. Thank you. Thank you. So the DX is 30.5 millimeters. Okay. 30.5. So we're gonna look at it from here and have circle, just gonna extrude cut, circle of whatever, depending on the screw that we're gonna use. So this is gonna be 30.5 millimeters. Perfection. Perfecto. This is gonna have to be horizontal with that. It's gonna have to also be, so if it's horizontal, it cannot go up and down, but it can still go right and left. It actually is. Let's do whatever dimensions for now. Actually, you know what? I have an idea. Let's have it the same screw size as the screw that goes in here. So we can look at this top side. A screw goes in here that has the measurements of 2.5 millimeter diameter. Nice. Or one that's 3 millimeter diameter. So we're gonna do 3. Let's do 3. Actually, let's do 2.5, and if the screw is a little bit bigger, it can just eat away at the material a little bit. Just, yeah. I know, it's not ideal. But until we know what we're dealing with, that's what we're gonna do. Alright. Smart dimensions, let's do 2.5 millimeters. In most bracket designs, the only screws in the bracket are the ones on the sides, not the horns screw. Well, we're gonna see what happens. We're just testing things out, so all of that can be readjusted at will. As long as we made everything right, nothing is gonna go wanky on us if we try to change it. So it's gonna be easily changeable later on if we do need it. Through all. Cool. Cool. Alright. Now, we need, from this side, we need to do extrude boss. Let's do something like, yep, we did say that we're gonna extrude this. Come on, work with me here. I'm gonna do something like this. We're gonna do it to be 5 millimeters. Yep. Alright, let's do 2. Actually, no, 1.5 centimeters. Yep. So we can give it a little bit of space for the screws to set in. Let's as well do this. Nope, this. And let's mirror along. Where is it? I see you. Yep, along this. And let's mirror this. Perfect. Perfect. Okay. We're gonna save that. And I'll tell you why we're saving it now, before we do the screws for the servo, because we can do it in a very smart way. Where was I gonna do that? Servo bracket. Where was I gonna save that? Oh yeah, here. Okay. Since we saved that, let's go ahead and close it. Let's close this one as well. Okay, so we're gonna insert it here. Insert servo bracket here. We're gonna grab that servo, mate it, with that. Okay, and then mate this with that. Okay, perfect. And then just let me see the side. Let me see the side. Okay, so we are gonna look at it from the top and then go to this item and do sketch on it. What was I gonna do? Where is it? Yep, just sketch. Yeah. Just normal sketch on this. If start sketch with context of the assembly rather than the part. I know. Thank you. Thank you for the information. We're gonna sketch here these. Perfect. Let's extrude. No, let's do. Where is it? Thanks. Now let's. Where is the extrude? I forget a lot, so it's cool. We're gonna figure everything out. Yeah, extrude cut. Select the plane. That's the plane. Select what to extrude. I was gonna extrude that, but okay. Okay, let's do this. I'm gonna remove that. We're gonna assembly, extrude cut, grab that, have this. Bada bing, bada boom. And we gonna extrude. Bam. Bam to the zam. Come on. Please don't embarrass me. Oh no. Oh no. No, no. That's too thick. Thick boy. Okay. We're gonna do something here. Let's see. We can make this thinner, but I mean, how thin? So for now, nah, it's cool. Where? Don't worry about the delays. It's probably my internet. We're gonna do, instead of line, we're gonna do up to 2 centimeters. So we have a little bit of space to screw things by hand, but we're gonna adjust that anyway, because this ain't working. Okay, so let's go back to actually, let's look at it from here, or look at it where. So I need this measurement. I need this. Evaluate, measure. Let's do this to this. 0.11 centimeters. Where's that considered from? Yep, that's the distance that I need. 0.11 centimeters. Cool. Cool. Let's open part. And made the whole structure as well. We're using threaded inserts of the bracket anyway, so it's better to actually make it thicker. Well, true. Or let me try this and see if it's gonna get too thin. If it's gonna get too thin, then yes, we're gonna use threaded ones. If not, then let's just try this first. Probably I'm gonna have to have this. What was I saying? 0.11 centimeters. So, where this? Edit sketch. Let's look at it here. So, 0.11. What was that? 0.11 centimeters. So that's. I need from that to that to be 0.11, which is considered what in millimeters? So that's 1.1 milli. Okay, so 1.1 milli. So let's say 2.2. So let's say 40 plus 2.2 millimeters, and then that doesn't matter actually. Yep. Let's do this. Nope. Okay. Now let's go to the assembly and see how it affected that. It's updating. Hey, let's go. Let's go. Nice. Way better. way better. How's that? Let me know, let me know, let me know. Cool. I like that. Like that a lot. Uy, can see. Let's just take it away here or something. Just put that aside. Probably pissing off a lot of people by keeping things unmated. But do I look like I give up? It's true. It's true. uh, but that is much, much better than what was happening before. We can even actually make this thinner. So we can have this to be only 1 centimeter instead of 1.5 centimeter. Because all of this extra stuff doesn't matter. What else? What else? What else? What up? Yeah. Let's go make it a little bit thinner. Because it will annoy me. Edit sketch. Actually, no. We're trying to edit the... What changes? I didn't do any changes yet. Let's edit the feature. So that would be just that. Cool. Nice. Much better. Alright, so that's done. Yeah, much, much better. Oh my god. That's awesome. Okay, we're gonna have an opening for the chords, of course, later. We're actually gonna have this made at like a very big rectangle here. But for now, as I said, it's just for simulation. We're gonna fix everything later. Don't worry. Don't get all triggered on me. But everything's gonna be fixed. Let's just focus on how to make these connect with this, connect with that. So we need a bracket here. Let's go for that. Let's do new. Please don't stop working now. I saved. Rebuild and save, please. Alright. What do we have here? Okay. We're gonna go for a new part. Please click. We're gonna do... Where do we want to look at it? We want to look at it from the top. I think... Huh. Yeah, we're gonna look at it from the top. We're gonna do this. We're gonna do that. Nice. Okay. Now, we need the dimensions for this to be... Let's do this. Let's go back to where is it? Where is it?
Where is it?
Yeah. Okay, there. Open this. Here. So, how it is oriented right now, the bracket is gonna go this way, so it's gonna go from here. I don't know if you guys, yep, you can see that. It's gonna go this way. That's why we open, then open it down, and we open and open it up. So, so since it's gonna be inserted that way, I need to find that width and have it like doubled or something. Evaluate, measure from here to here. 20, and then we're just gonna double. It's gonna be like 40 millimeters, and then it's gonna walk away from that as, so that's that, and that's from here. I need to know what it is from here to the very bottom. I'm not even clicking measure. From here to the very bottom, where is that dimension? It's the dy. Okay, so 47, we're gonna make it 50. And yeah, we're gonna make it 50, and we're gonna take it from there. So let's make it 50 first. So we said 20, we're gonna double it to be 40 by 50, and then see how it goes from there. So 40 by 50. 40. Wait, this is gonna be the 40, so this is gonna be, actually nope, let's make this the 50. Oh, that's a big arrow. Let's have this to be 40 millimeter. Yeah. We're gonna have it as a thickness of 5 millimeters as well. And then we're gonna go from here. We're gonna do extrude boss as well. From the 40s, right? Yep, from the 40s. Yeah. Right. We're gonna do this. We're gonna do this. And then this. I'm gonna trim that. There. We're gonna have that be mated with that as in vertical. So this can still grow, right? Oh yeah, it can still go up and down, so that's why it's not done properly. Let's do, how far do we want it to go? We can do 2 centimeters. Wow, that's okay. We're gonna see how it goes first. Nope, other way around, buddy. Where? Up to blind. We're gonna have it to be as well 5 millimeters, because that's the thickness. That's gonna fit everything that we're trying to do. So we did say 50, and then 5, and then 5. Yeah, wait. Let's do this. Let's mirror that. Mirror to here. Exactly, thank you. Nice. For now, let's have this have a just let's edit that sketch. Let's do this. We said it has a whole of, where was it? Let's look at this from here. So this is gonna go all the way through. Evaluate, measure from here to, let's say, here. So that's gonna be 3 millimeters. As a radius, so that's gonna be 6 millimeter diameter. Perfect. Okay. Now, let's save that as C bracket. Now that that's saved, we can close it and edit it from the inside if needed, from inside of the assembly. Insert. We're gonna get the C bracket and have it be here. So this is supposed to go like that. Let me show you. Where? Yep, there. Let's have that. And where is it? And that. Yeah, boy. Yeah, boy. That needs a lot more than that. Okay. Let's see what happens if we made this face and this face. Yep. Okay. So we need this to be more than 2 centimeters so it can move freely. But you get the point, right? So you get that this is just gonna move like this. There it is. There it is. Yeah. Alright. Alright. Let's edit this. What was I gonna do? Edit. I need to edit sketch. I need to edit this sketch. So instead of instead of 1.5 centimeter, we're gonna actually, instead of 2, we're gonna have it to be What? That's actually not the one that I need. Discard. I need the one that. So we can go in here. Where is it? That? Yep. We're gonna edit that sketch. Yeah. Instead of that, instead of 2 centimeters, let's make it 4. Because I feel that that's gonna be a lot better. Huh? You took it as 4 meters, right? Yep, because it's MKS. My bad. Please don't be dumb. Please. God damn it. For centimeters, please. Thank you. Thank you. Much, much better. Oh my god, look at that. Look at that beauty. Come on. Tell me that's not beautiful. Come on. So, if we look at it like that, this is how far it can go. It cannot touch that. So literally this is as far as it can go this way, and as far as it can go that way. Which is all we need, to be honest. We just needed to have a 90-degree angle. So from here, I can still shave a little bit of it from these sides. Like shave this and this, depending on the stresses and analysis and all of that, of course. Or actually make this just a little bit longer, or have all of this thin just go out a little bit instead of having it here. So we did it away 2 centimeters, we're gonna have it 1.5 centimeter away. So there are a lot of things that we can do, but again, as we said, we're just trying to simulate everything. So far, this is gonna work out great. What were we gonna do other than that? Let's do this. I was gonna do something and I forgot. Yeah. I legit just forgot. We're gonna try to make this into that. That needs to make to another bracket, which needs to make into that. That needs to be here. So let's grab that. And check how it mates with this. We're gonna cancel this mate later, but just hear me out. I need to see how it fits. Okay, let's grab all of that outside. Huh. Okay, let's mate that with this. Okay. So if all of this moves, we just need this to mate with something for now. Let's have it stuck here or something. Okay. Nope. Don't do that. Don't do that. We're gonna cancel all these mates. Don't worry. Okay. Okay. That's what this can do. Of course, with limitations. But all of this is just gonna be like flip, because this is the what's it called? The femur. So this is, yep, the femur. Yay! I know my stuff. So after the femur, we're gonna have the tibia and all of that. But for now, I think that's gonna be it for this stream. We've been streaming for an hour and 20 minutes. Um, you guys probably get the idea. So what I'm gonna do in my free time, I'm just gonna basically insert all of these C brackets here, 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 and here, and just grab a bunch of these brackets and have them inside of these servos. It's gonna be very boring jobs, don't worry. I'm not gonna do any new things not in front of you guys. So probably I'm gonna just finalize all of this by today, the brackets and everything. And then by tomorrow's live, I believe I'm gonna be finishing a lot of stuff, which is basically once these brackets are put, we're gonna mate that bracket with the other one that's mated here and start moving our femur. And then if all goes well in that stream, in the same stream I might just add the tibia to it. And if that's done, I'm gonna start simulating. But for now, it's been good progress today actually. Doing these brackets is the most critical part because this is gonna mate to everything. This is where it all starts. So far we're doing great progress, and I'll see you guys next stream, which is tomorrow, hopefully. If it's not tomorrow, I'll let you know, but so far I believe I'm gonna do it tomorrow, and hopefully everything works out well. So thanks to our great leader Farid for streaming in and giving me his tips, and see you guys tomorrow. So you have yourselves a great day.